students, in the last class we have discussed relation. What are domain and range of relation that we have seen in the last class. So here let us discuss different types of relation. There are different types of relation based on specific properties and conditions. Some of the types are, say, empty relation. So what is empty relation? To define empty relation, let us take a non-empty set A and the relation R. The relation R in a set A is said to be empty if the relation R contains no element. The relation R is equal to empty set. So what does it mean? For example, let us think of a set A consisting of 25 students in a class. Then let us define a relation R on the set A as getting an elephant in the class. So what is class? The class contains 25 students. So what is relation on the set A? The relation R on the set A is defined as getting an elephant in the class. Getting an elephant in the class means getting an elephant from the set of 25 students. So is it possible to find an elephant from the set of 25 students? No, it is not possible. That's why the relation will contain no element. That's why the relation R in this case is an empty relation. Now let us see what is universal relation. Suppose A is a set and R is a relation on the set A. Then the relation R is said to be a universal relation if every element of A is related to every other elements of A. In this case, the relation R must be equal to the Cartesian product of the set A. Say for example, if a set A contains element 1, 2, 3, then in the relation R, the elements will be 1, 1, 1, 2, 1, 3, dot, 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 like this. All these elements. So here the elements are 1, 2, and 3. So the relation R to be a universal relation, every element must be related to every other elements in this set. So in this relation, we can see that 1 is related to 1, 1 related to 2, 1 is related to 3. Similarly, 2 is related to 1, 2 is related to 2, 2 is related to 3, and so on. 3 is related to 1, 3 is related to 2, 3 is related to 3. So in this case, we see that every element of the set containing the elements 1, 2, and 3 is related to every other elements on this set. That's why it is a universal relation. And note that the empty relation and universal relation is also called trivial relation. Next type of relation is identity relation. So what is identity relation? Suppose A is a set containing some elements, then identity relation denoted by I is defined as the set containing the pair of elements where uh, each element of the pair are same. Means A, B, B, C, C. If a relation I contains A, B, B, C, C, dot, 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 then it is called identity relation. For example, in case of throwing two dice, अगर दो डाइस को हम एक ही बार फेंक रहे हैं या हम सिंगल डाइस को दो बार फेंक रहे हैं, तो ये दोनों इवन जो है सेम होता है। सपोज इसमें हम दो डाइस को साथ में फेंक रहे हैं, तो डाइस में नंबरिंग नंबरिंग क्या होता है? डाइस में नंबरिंग होता है 1 होता है, 2 होता है, 3, 4, 5, मैक्सिमम 6 होता है ना। तो सपोज हम एक डाइस को फेंक दिया, फर्स्ट तोला में 1 आया, सेकेंड वाला में भी 1 आ गया, ऐसा भी हो सकता है, पॉसिबल है। या तो फर्स्ट वाला में 1 आ गया, सेकेंड वाला में 2 आ सकता है, ऐसे हो सकता है, पॉसिबल है। डॉट डॉट डॉट, बहुत सारा पॉसिबिलिटीज है। सिमिलरली फर्स्ट वाला में 6 आया, सेकेंड वाला में 6 आया, है ना, ऐसा हो सकता है। सो दिस आर द पॉसिबल आउटकम्स ऑन थ्रोइंग 2 डाइस ना। तो टोटल पॉसिबल आउटकम्स कितना होगा? 36 पॉसिबल आउटकम्स होगा। आप सब निकाल सकते हैं, 1 1 1 2 1 3 1 4 1 5 1 6, then 2 1 2 2 2 3 2 4 2 5 2 6, and so on. You will get 36 pairs in case of throwing 2 dice at a time. So if we define a relation on this set as r equal to 1 1 2 r equal to the set that contains 1 1 2 2 3 3 4 4 5 5 6 6, तो ये केस में r किस तरह से डिफाइन है? So the element 1 is related to 1 itself, 2 is related to 2 itself, 3 is related to 3 itself, so on, 6 is related to 6 itself. तो इस तरह का एलिमेंट्स अगर है, पेयर ऑफ एलिमेंट्स है, तो R को हम आइडेंटिटी रिलेशंस बोलेगा, ठीक है। व्हाट इज इनवर्स रिलेशन? Suppose R is a relation from the set A to B, which is the it is actually R is a subset of A cross B. R belongs to A cross B नहीं होगा, R is a subset of A cross B. Then the inverse relation is denoted by R inverse, which is a relation from B to A. तो रिलेशन R जो है A to B है, तो उसका इनवर्स रिलेशन जो है B to A होगा, and it is denoted and defined by this expression. रिलेशन R का एलिमेंट सपोज A B है, so that A belongs to A and B belongs to B है, then इसका इनवर्स रिलेशन होगा R इनवर्स, which is equal to B A. सो दोनों में क्या डिफरेंस है? ये एलिमेंट का पोजीशन चेंज हो गया, ठीक है। सो ये यहाँ पे आ गया, ये यहाँ पे चला गया, तो ये डिफरेंस है दोनों में, रिलेशन और उसका इनवर्स में। व्हाट इज रिफ्लेक्सिव रिलेशन? If every element of a set A maps to itself, then the relation is said to be reflexive relation. For example, if A belongs to A, then AA must be an element of the relation R, or it is denoted by A is related to B for all A belongs to A. तो रिलेशन है 1 2 1 3, तो ये सपोज एक रिलेशन है, तो ये रिफ्लेक्सिव रिलेशन है कि नहीं, हम कैसे चेक करेंगे? सो रिफ्लेक्सिव रिलेशन होने के लिए क्या होना पड़ेगा? फॉर ऑल ए बिलोंग्स टू द सेट ए, है ना। तो यहाँ में सेट ए जो है एलिमेंट्स क्या होगा? 1 2 3 है, सपोज ये जो है सेट ऑफ एलिमेंट्स है ए। तो ये रिफ्लेक्सिव होने के लिए हमको ये इसको चेक करना पड़ेगा, तो इसमें ये सेटिस्फाई कर रहा है कि नहीं हो, देखो। सपोज कोई भी एक एलिमेंट लीजिए 1, सो 1 1 1, so 1 1 must belong to R. So here 1 1. Again another element 2 2 must belong to R. So here's 2 2. Next 3 3 must belong to R here. So so in this case, so every element is related to itself.